Hello, this is Will Soutter from AZO Nano, and we're here at the 10th Seeing at the Nanoscale event at the rather grand surroundings of the Wills Memorial Building in Bristol. And I'm here with Dr Mark Munch, who's the president of Bruker Nano Surfaces. He's kindly given us some of his time to answer some questions. Hi Mark.
Hello.
So Mark, it's been nearly a year and a half since the transition from VICO metrology to Bruker Nano Surfaces. I'm sure there have been many changes during that process. What key changes have you seen?
Well, there have been really positive changes. It's been a smooth transition. We found really a better home with Bruker because they're a scientific instrument company, and it really has become it's a better fit for us. So we've seen enhanced investment in our sales coverage, in our service coverage, in our facilities. So we've upgraded our facilities around the world. We've upgraded our factories, and we've had a lot of tremendous support for partnerships and for acquisitions. In fact, just recently, end of last year, we completed an acquisition in Campbell, California, the acquisition of CETR. So it's been a very, very supportive environment. So those have been kind of four areas of really positive change for us. And we've done all that, integrating into Bruker without slowing down in innovation at all. So we're putting out a number of new products, just as we did under VICO. That rate of innovation has just continued under Bruker.
So what would you see as the key challenges in the near future with more widespread AFM adoption?
Yeah, these have really been long-standing challenges for the whole AFM industry in terms of adoption. Ease of use. AFMs traditionally are known to be very hard to use. You have to be very specialized in order to get really high-quality, good results. So we've been focusing on ease of use, and you see that manifested by invention of peak force tapping mode, of which within that mode we offer Scan Assist. So you find Icon with Scan Assist, multi-mode with Scan Assist, Bioscope Catalyst with Scan Assist. So ease of use is very important, and we've been charging down that path, leading the way for the industry. In addition to that, faster imaging. To take a really good high-quality image traditionally has been you have to be very patient, and we've changed the game in that, allowing 100 times faster in terms of image acquisition speed. And then also, while increasing ease of use and fast scanning at the same time, increasing performance range, going down to softer materials without sample damage, and really broadening the applications. So these have been major challenges, and I think we've been making really good progress around all three fronts. Yeah, it's been going very well.
So with all these advances, what direction do you see nanoscience research going and developing using these AFM techniques?
Yeah, so in addition to ease of use and fast imaging and everything I just talked about, which we're doing, going beyond topography is really key. So we are providing fast topography and ease of use towards topography, but also providing quantitative nanoscale information, such as quantitative nanomechanical information, quantitative nanoelectrical information, and quantitative chemical ID, because scientists want to understand, hey, you've given me a really interesting picture of the surface, some really interesting topography. Now tell me more about what is it. So what is it mechanically, what is it electrically, what is it chemically? And so these are really important research directions that we are also investing in. Yeah.
What would you say are the key advantages that Bruker AFM systems give over other competitors in the field?
Yeah, so of course I'm biased in my answer to this, but I do really think we lead the way in breadth of products to suit any application. We have the largest offering in products and largest offering in modes. So we have a very complete set of products and mode sets, electrical modes, topography modes, and mechanical modes. In addition to that, we really have led the way in terms of instrument stability for large scanning. Dimension Icon is a very stable platform, and we've been able to achieve atomic scale resolution over large scans, and that's a first for the industry, to just be able to scan over that range and image atomic scale resolution. And then furthermore, doing that while going fast. So our Dimension Fast Scan images atomic scale, but over large scan lengths. So, there's a number of advantages that we have that we're very, very proud of. And I think our development teams and research teams have done a very good job kind of leading the way. And that's going to help the industry because, what we do to help our customers really helps push the whole industry forward. Yeah.
Great. So seeing at the Nanoscale is a great event that's clearly hugely popular in the AFM community. What are the plans for the event next year?
Yeah, so we've always been seen at Nanoscale as a key event because it really facilitates technical exchange and brings the industry together to exchange ideas. And we've selected some very nice locations such as Bristol to do that. But some of the changes we see are we're actually going to enhance the number of collaborations that we have, really leverage the scene brand, and because we've built quite a brand for the event. And I think it's really important that we leverage that by building on the number of collaborations, by doing more scene events, but also increasing the geographic reach. We've often go back to Santa Barbara, for example, on every other scene at the Nanoscale. And so we're going to explore really other geographies. And for example, you'll see not just bouncing back and forth between US and Europe, you'll see us actually going to other regions of the world. So because we built this brand and because it's a really effective conference, I think, why not leverage it more broadly? Mm-hmm. Yeah.
Great. That's fantastic. Thanks a lot, Mark. And good luck with the expansion of the event next year and all these developments in the future.
Yeah, you're welcome. Yeah, nice to meet you.